Exercise 7b, question number 1. Explain what you understand by following terms. Critical value. So critical value is the first value to fall inside of the critical region. So now you understand. There's no need to explain now. So the region critical region is is a region of the probability of distribution which, if the test statistic fall within it, would cause you to reject the null hypothesis. A critical region is a region of the probability distribution. So these are the standard answers. The acceptance region is the area in which we accept the null hypothesis. So the test statistic has a distribution X binomial. So they are doing 10 trials in this sum. It's like 10 times tossing the coin, and P value is we need to test H naught is P equals 0.2. This is the belief. So we need to distribution, not the 0.41 or any other one. We need 0.2 distribution. How the probability distributes according to the this value. So H1 is P greater than 0.2. So this is, we have to use the upper tail in this one. Significant level is given 5%. It means 0.05. This is a part of that distribution. This is a cumulative one. Cumulative distribution for 10 trials with the probability of p-value success value is 0.2. Now, so this is upper tail, so we have to come from here. We'll take the probability of getting 5 up to 6, up to this value. Probability of x 6 or more. Is 1 minus probability of x less than or equal to 5. So that is going to be 1 minus 0.9936. I just look at the area and I pick up these values because I need a value to make 0.5. So I want to check 1 minus values equals 0.0064, and sorry, this is greater than or equal to 6, and so this is as a percentage 0.64. Probability of x greater than or equal to 5 mean 1 minus x less than or equal to 4. So up to 4 here, up to 5 now, this probability. When you minus 0.9672, so that probability is going to be 0.0328, that is 3.28 as a percentage. And so it's still not 5, still not 0.5, so we need to go further. So when we go further, the other one, probability of x greater than or equal to 4 is 1 minus x less than or equal to 3. So 1 minus 0.8971. 8791 is going to be 0.1209, which is 12.09. 12 is going to be 12%. So we are in the upper tail or only lower tail. We don't try to find the closest one, but however this is the closest one. In that case, up to 5 and greater than is the critical region. uh, Critical value, the first value fall into the region is 5. So critical region, that is going to be 5 greater than x greater than or equal to 10, and actual significance level is 3.28. Question number 3, test statistics as usual follow binomial. 20 trials there, and what is the p is going to be 0.15. So h naught is p equals 0.15. H1 is p less than 0.15. So we know that this is going to be a one tail test and it's from the lower side. So significance level testing is 5%. So we need to find the critical region. When I look at, so this is the cumulative graph from the table. You can see 0 and 1. So this is when you look at, you can see this is 3%. This is going to be 17%. The only answer is this one. So, but we have to write probability of x less than or equal to 0 mean there is no meaning for that. So there is no less unless there is no minus. So probability of x equals 0 is 0.38 038. So that is as a percentage 3.88. Probability of x less than or equal to 1, that is going to be 0.1756, that is 17.56. Now we can see we need the 5% significant, then the only possibility is 0. Now the critical value is 0, and critical region is x equal 0, and critical region and actual significance level is 5%. Sorry, 3.88%. Number 4, same as this distribution, follow binomial 20 and 0.4. Now h naught is p equals 0.4, and null hypothesis is p not equal to, it means this is going to be a two tails test. 5% significant level, the given 5% significant level, it means it's going to be 2.5 both side. Um, I jot down accordingly. So this is the cumulative one for 0.4 and x values. Um, so when you look at, we can clearly see that we need 0.025 from both sides. Now this is more than 0.025. This is less than. So that is one thing we can look at. Probability x less than or equal to 3 is 0.0160, which is 1.6%, and x less than or equal to 4 is 0.0510, that is 5.101%. Now also we want to check that how far those two values from 0.025. I want these two values because much closer one we have to select. So if I minus 0.025 minus 0.0160 and then the other check. So this is the bigger number, 0.0510 minus 0.025. So the critical value is now when we look at this value is more smaller than this one, so then it's going to be the critical value is x equal 3. So critical region is 0 greater than x greater than or 3. From the now lower tail we completed, so this is the critical region, and actual significant level is 1.6 percent. And now the upper tail, it's going to be, let's consider x less than or equal to 12, greater than or equal to 12 is 1 minus probability x less than or equal to 11. So up to 12, it means 1 minus this amount, that is 1 minus 0.9435, so 0.50565, and probability of x greater than or equal to 13. So the 11 value is 12. So after 12, so 11 value is 0.9435, and this is right. Okay, and probability less than x less than or equal to 12. So 1 minus 0.9790, that is going to be 0.0210. So up to 13, 0. Okay, what as a percentage, 2.1, 2.1, and this is 5.65. So up to here it is 2.1, and up to 12 it is 5.65. So now for the time being we have 13, because that is less than, so actually we have to write this one, this is greater than the previous one. I forgot to write that. This is greater than 0.025, this is less than 0.025. 5. Make sure that the first one also, when you do that, you have to do it. Then the second task, we want to compare with this distance from 0.025, 0 minus 0.0120. Then the other one, 0.0565 minus 0.025. Uh, so when we minus this one, this is also, this one is closer to the um, 0.025. So 0.025. Then the 13 is much closer. This distance, when you compare with 12, the 13 is much closer. Then the upper tail is going to be the critical value. Uh, Critical value is 13, and the critical region is going to be 13 greater than or equal to 20, and actual percentage is 2.10 on that side. Then total actual is 7, and this is 3.7, and the actual significance level is 3.7. Question number 5. um, Variable x is following binomial 20, and h naught is 0.22, 0.18, and h1 is p less than, so this is going to be a lower tail test. 0 and 1, and cumulative probability for 0.18 is going to be 0.0189 and 0.1018. Now probability of x, the significance level given in this one, 1%, 0.01. Now probability of x equals 0 is 0.0189, that is 1.89 as a percent, and probability of x less than or equal to 1 is going to be 0.1018. This is going to be 10.18%. So then the critical value, so significance level is 1%, 1%, and then the possible critical value is x equal 0. And the critical region is x equals 0. Question number 6. They all same type of questions now. X follow binomial. So sample size is 10, 10 test, and H noise P is equal to 0.22. So this is 0.22, and H1 P not equal to 0.22. So this is two tail test. on both sides. The significance level is given 1%. So 1%, it means 0.5% for both sides. It means 0.005 and 0.005. For this one, you have to use a calculator because we can't get this one from the table. You know how to do it. We discussed in our discussion. This is I just wrote down the cumulative frequency, and this is a good question actually. As a mathematician, statistician, it's your decision to do what to do. Basically, now when you take the lower tail, uh, this probability of x equal 3, probability of x equal 0 is 0.0833, which is 8.33%. So this is 1%. So basically, according to this one, the starting point is out because you can't take 8.3, is too much. And this is according to me. It may change according to you. Then I will go the low upper tail. So I will take probability of x greater than or equal to 8. Probability of x greater than or equal to 8 mean 1 minus probability less than or equal to 7. So 1 minus, that is 0.9998, which is 0.0002. So this is going to be 0.02%. Now probability of x greater than or equal to 7 is x less than or equal to 6. That is 1 minus 0.9894. That is going to be 0.0106. I'll delete this one and I'll bring it to this one up because I need the space for this. I wrote this everything in top. So up to 8, that is 0.02 up, and up to 7 it is going to be 1.06. Now, so this is a lower tail. We can't think about anything because it is very far. And then the upper tail. So one is smaller, the other one is greater than 0.5. So when you look at which one is closer, this one or this one is closer to 0.0055, 5%, 0.5%, because 1% is significance. And when you check which one is closer to 0.005, you will see that this one is closer to 0.005 than this one. Then according to that, there is no critical region for this one, and there is a critical region for this one, that is x equal 8 onwards. So 8 greater than, x greater than, that's a small change I have to do. This is 9, this value is 998, so I have to calculate this one again. This 9984, and this is going to be 0.0016. 0.0016. So as a percentage, 0.16. So this is now less than 0.5. Then probability x greater than or equal to 6 equal probability x less than or equal to 5. That is 9896. 1 minus 0.9896. This is going to be 0.0104 as a percentage, that is 1.04% and greater than 0.5%. Now when you look at which one is closer to 0.5, so one is 0.5 minus in terms of the percentage, 0.5 minus 0.16 versus 1.04 minus 0.5%. So now we can see that this is bigger, hence we have to stay with this one. Then the critical value is x equals 7 and the region is x 7 greater than x greater than 10. Now according to this one, the actual significance level is actual significance, so this side nothing, and this one 0.16, totally 0.16. But if you decide to add from one from lower tail, then x equals 0 is the only one you can add. Then so this is the critical value and critical region x equals 0, and this will stay the same. So x equals 7 and the area is x less than 10, and this one then an actual significant level, because this one, this x equals 0 value give 8.33%, and this value is give 0.16%. So the total is going to be 8.33 plus 0.16, that is 948449, approximately 85 as a percentage, or number 0.085 as a probability. As a statistician, assume that according to my view, I am not going to add this 8.33, because if client asks 1% significant level, so I have to stay around that figure. I don't want to go like 8.33 figure, that is 8.45 making to total. So instead of that, I might think differently. I may go for, instead of from both side 1, I'll go for 1% total, and 1% total, then I can see. So I don't want, in that case I'm not going to involve with this one. This is a very big number. Then I'm looking to the total one. Then this is a good one, 1.04, and the other one is going to be far over. So this is the, according to 1, this is less than. If it is 1, then this is going to be less than 1%, less than, this is more than. So now this is the boundary, and this one is much closer. Then I will stay with the critical level is 6. Um, critical level is 6. Critical critical value is 6, and region is 6 greater than x greater than 10, and actual significance level is going to be 1.04. So that is better. And that 8.33 and 0.16, 1.04, they all depend on the cost of the cost and the damage. For example, if you work with Apple or any other system, sometimes this is all right, okay. But if you work with the diamond, like very costly thing, then point one is also very important. Then this is very crucial. So likewise, it depend on the, so you have to assess accordingly. Question number 7. The mechanical component fail on average 3 out of every 10. Now this is a story from the population. So 3 out of 10 is average failing. P value is 3 out of 10 failing, which is 0.3. And engineer designed new system, and so he thought, now according to the new system, now this P is less than 3 over 10. It's reduced. So he want to check this one, then he take 20 sample. This is the setup of this question. From the history, they will give from the population, they will give information data, population data. It can be a x bar mean, or it can be a probability usually. But to apply binomial, then this has to be a probability. It can't be any other forms. According to this one, x follow 20 trials and 0.3 h naught is p equal 0.3. We believe it is reduced, so h1 has to be less than 0.3. So this is lower tail test. So the first question, describe the test statistics. The test number of components, number of failures. X is number of failures out of 20. 20, they are components. So we want to find, so this is the part B, and we want to find the critical region and the actual significance level. So we have to use the table for this one. We are testing here with the 5% significant level. So probability for x less than or equal to 2 is 0.0355, and that percentage is 3.55, and probability of x less than or equal to 3 is going to be 0.1071. So this is less than 5%, and this is going to be 10.71. As a percentage, this is greater than 5%. Hence, the critical region is x less than or equal to 2, and the critical value is going to be 2. example x equal to, and part D, the actual significant level. Actual significance level is 0.3.55. Question number 8. Seedling communicates 36 on average. 36 on average, 12 seedlings survive to be planted. So that is a probability of that history. So P is going to be 12 out of 36, which is 1 out of 3. And they think that the new fertilizer improve the survival rate. It means uh, X follow binomial. Still the tray number trials are 36, and this is going to be 1/3. And the sixth question describe the suitable null hypothesis, so it's not equal probability of 1/3, and increase the survival rate, then H1 is probably greater than 1 over third. And using the 10% significant level, so part B 10% significant level, we want to find the uh, critical region. So probability of x greater than or equal to 17 is 1 minus probability of uh, less than or equal to 16. So that is going to be 1 minus 0.9416. That is 0.584, which is 58 percent. So this is less than 10%. And probability of x greater than, now up to here it is 5.84. Now let's start from here. 16, that is 1 minus, or x less than or equal to 15, that is 1 minus 0.8906 equal 0.1094 equal 10.94% greater than 10%. Hence critical region is 17 greater than or equal to x greater than 20. And part C, we need the actual significance level, same as probability of incorrect rejecting next node. Probability of incorrectly rejecting H naught is 5.84. Question number 9. The restaurant owner noticed that her customer typically chooses lasagne on 1/5. So P is 1/5, 0.2. She changed the recipe, and he believes that customer changed the proportion of chosen lasagne. Now suggest a suitable model, and yeah, so X test statistics for a given time, in given time, uh, the number of customers choosing lasagne less out of total number of order oblates, then H naught is P equal half, and H1 is P not equal to half. It's changed. It could be more or less. So, so we had to work both tails, lower tail and upper tail. So B, assume H naught is true, then X follow binomial 25 0 point. This is something we really need for hypothesis testing. Sometime I am missing as well. Assume that H naught is true. Make sure that that is one condition for to for the hypothesis testing. So the significance level is 5. C is 5. It means from lower and upper 2.5, 2.5 each. So probability of x less than or equal to 0, when you look at from the table, which is 0.38%, and probability of x less than or equal to 1 is going to be 0.0274, which is 2.74%. Now when you look at the closer, this one is closer to 2.5%, hence the critical region, critical value is x equal 1, and critical region 0 greater than x greater than or equal to 1. So this is closer to 2.5%. And when you, this is from the lower tail, then upper tail, probability of x greater than or equal to 10 is 1 minus probability of x less than or equal to 9, that is 1 minus 0.98 0.9827, that is 0.0173, and this is less than 2.5. This is equal to 1.73 less than 2.5%, and less 1.73 and less than 2.5%, and probability of x greater than or equal to 11, 9 is 1 minus probability x less than or equal to 10, sorry 8, and this is going to be 1 minus 0.9532 is 0.0468, which is 4.68 greater than 2.5, but this is closer to 2.5. So sorry, this is not the 1.73 is closer to 2.5. This is closer to 2.5. Hence, critical value is x equal 10 and critical region is 10 greater than or x greater than 25. But part, part C is state the probability of incorrectly rejecting H naught. So probability of incorrectly rejecting H naught or actual significant or actual significance level. This is going to be from here 2.74 plus 1.73, that is going to be 4.47%. So overall it is 5% and actually is 4.47. So it is very close at 4.7. So it is a good selection. If I revise again that this is so important, assume H naught is true, then because all hypothesis tests depend on this one, this assumption, assume H naught is true, then